Hi students, today we're going to be looking at reducing and enlarging formulas, which is a very useful concept that we use to make products when we have master formulas. So the objectives for this lesson are: one, we're going to define what reducing and enlarging formula means. What does it mean in terms of pharmaceutical calculations? You should be able, at the end of the lesson, be able to reduce and enlarge formulas using master formula with 100% accuracy. We also want for you to be able to perform calculations to reduce concentration of one or more ingredients in a formulation whilst maintaining the proportion of the base. Now, this will not be covered in this lesson, although it's an objective listed here. We will do this when we do dilutions and concentrations. Your reading assignments, you have two materials that are relevant to this calculations. They are your pharmaceutical calculations. I have listed here the 13th edition, but the 15th edition is already out. And we also have the manual. Please note the chapters, and I would like for you to go through the material, having gone through this lesson, and try your hand at the calculations, especially in your textbook, the pharmaceutical calculations textbook. It has questions at the end of that chapter, and the answers are also there as well. So let's get started. Now, very often as a compounder, you are going to be required to prepare formulations from a master formula. Master formula is simply a recipe. If you look in your cookbooks, you will see a recipe, for example, for making potato pudding, which happens to be my favorite pudding. You will see how many pounds of potatoes you need, how many pounds of flour if you're adding that, the amount of vanilla, etc. If you follow this recipe, you should be able theoretically to get the nice, moist, soft potato pudding that the person who wrote the cookbook is trying to convey to you. So it is similar in pharmaceutical calculations. You will see these master formula with the list of the ingredients and the amount, and it's usually written in small amounts, say all ingredients listed, all to be made up to volume to 1 ml using water as a vehicle, or you may see it all the ingredients listed and all to be included in a ointment using a base with a final weight of say 100 grams. So these are the master formulas that you can now manipulate. If I say don't want to make 100 grams of that ointment and I want to make 25 grams, there should be a way for me to make do with that master formula by doing the calculations to see the amount of ingredients that will be needed to prepare my ointment. Okay, so we're going to use this master formula for salicylic acid and sulfur ointment as a demonstration for reducing the formula. So we're going to be using this formula to produce 30 grams of ointment. When we look at the master formula, however, we see that there are two active ingredients and one base. The two active ingredients are salicylic acid, which is one part of the formulation, and precipitated sulfur, which accounts for 8 parts, and soft paraffin, which accounts for 91 parts. If you look at this, it means then that the whole or the total number of parts will be 100. That means my salicylic acid and sulfur ointment will be 100 parts, and in that 100 parts, you're going to find one part of it being salicylic acid, 8 parts being precipitated sulfur, and 91 parts being the soft paraffin, which happens to be the base that's carrying the active ingredients. All right, so we're going to be reducing the formula then. If we're going to be making 100 parts, which could be viewed as 100 grams because the ointment is made in terms of weight, then we are going to have to reduce the formula if we're going to produce 30 grams. So let's take the first ingredient, the salicylic acid, which is 1 part, or we could say 1 gram of that whole 100 gram of ointment. If 1 part of salicylic acid is contained in 100 parts of ointment, may also be expressed as grams, we will then say 1 gram of drug or 1 gram of the salicylic acid is going to be contained in 100 gram of the entire ointment. Then X parts of salicylic acid that will be contained in 30 gram of ointment needed would be 1 part over 100 parts, or you could say 1 gram over 100 grams times 30 grams, which will give you an amount of 0.3 grams. So that means if I'm going to make 30 grams of salicylic acid and sulfur ointment, I'm going to need 0.3 grams of salicylic acid. This is just a demonstration to show you that 100 grams is representative of the total number of parts. So 100 grams is the same as saying 100 parts of the ointment. So let's look at precipitated sulfur. Precipitated sulfur in this master formula has 8 parts, all of 8 parts in that total number of 100 parts. So if we say 8 grams of the drug or 8 grams of the precipitated sulfur is contained in 100 grams of the ointment, which is the same thing as saying 8 parts in 100 parts of the ointment, then we can determine how many parts or how many grams will be contained in 30 grams that we want to make. So X would be equal to 8 parts over 100 parts times 30 grams, which is 2.4 grams. Similarly, for soft paraffin, all of 91 parts are found in the entire 100 parts of the ointment. That means that most of the ointment is going to contain the soft paraffin. So 91 grams of paraffin is contained in 100 grams. How much will be contained in 30 grams? We got 27.3 grams. So the tradition is that once we have calculated the amount of ingredients needed for the amount that is requested, then we write a new formula. And the new formula will state that in order for me to make 30 grams of salicylic acid and sulfur ointment, I'm going to need 0.3 grams salicylic acid, 2.4 grams of precipitated sulfur, and 27.3 grams of soft paraffin. So that was an ointment, and it is recorded in weight, mass, grams. What if you got something that is liquid? Now, we already learned how to interpret a prescription, and we knew of the different abbreviation, Latin abbreviation, and what they mean. QS in this case means that you're not going to add 100 mils of calcium hydroxide. It means you're going to make sufficient amount such that you're adding up to 100 mils using calcium hydroxide. Let me say that again. This master formula is completely different from the one we had before. It listed the amounts of each ingredient that will be found in 100 parts or 100 grams of the preparation that we are trying to make. In this case, it's a liquid. And QS, if you remember from that last lesson that dealt with interpretation of prescriptions, QS means sufficient amount. So this 100 mils of calcium hydroxide does not mean that you're adding 100 mils of liquid. It means that you're adding sufficient amount of the liquid until you reach a final volume of 100 mils. So you're making up the volume. So this master formula is that of calamine lotion, and it contains 5 ingredients. The calamine and the zinc oxide would be the active ingredients. The glycerol, bentonite, and calcium hydroxide will be the excipients. Those are the drugs. Those are the ingredients, I'm sorry, other than the drug ingredient. So here they're asking us to make 30 mils of this um, lotion. We're reducing the formula because we're moving from 100 mil that is in the master formula to 30 mils. So let's look at calamine powder. 8 grams are found in 100 mils. So it's quite easy using ratio and proportion to determine how much of that powder will be contained in 30 mils, which is 2.4 grams. Zinc oxide powder, also 8 grams, 2.4 grams will be found in the 30 mils. The glycerol, 2 grams are found in every 100 mils. So if I'm making 30 mils, I'll have to have 0.6 grams. The bentonite magna is 25 mils in 100 mils, so therefore 30 mils will contain 7.5 mils. We are not going to do any calculation for calcium hydroxide because we are using that to add up to a final volume of 100 mils. So we don't know what that volume will be. We're just adding until we reach that 100 mil mark. As carrying out with the tradition of writing your new formula, the new formula will look like this. Oh, I'm very sorry. The new formula will be, let me go back. The new formula is going to be 2.4 grams of calamine powder, 2.4 grams of zinc oxide, glycerol 0.6 grams, and bentonite 7.5 mils, and we add up to 100 mils. What if we are making 1,000 mils? I'm sorry. What if we're making 1,000 mils from the master formula listed here? Then it means that we are going to have to now move from 100 mils to 1,000 mils. So clearly, the amount of ingredients that we are going to use are going to be much more than what we have in the master formula. So 80 grams for the calamine powder, 80 grams for the zinc oxide, 2 grams for the glycerol, and that should be 20 grams for the glycerol, and 250 mils for the bentonite. So our new formula now will be 80 grams calamine, zinc oxide 80, glycerol 20, 250 bentonite, and of course, we're going to add sufficient amount of calcium hydroxide to make 100 mils. So this is pretty simple. You just need to know what the final amount in the master formula is, what is the amount that you are required to prepare, and do ratio and proportion to determine the amounts of each ingredient. What if I don't want to go through all the steps of if 8 grams is in 100, then how much would be in 30? We can use a scaling factor. Now, this scaling factor is what we're going to use to calculate each ingredient depending on what we are increasing or reducing or enlarging or reducing the formula by. So if I'm enlarging the formula by 2, then I multiply each ingredient by 2. If I'm reducing the formula by 2, then I reduce the formula by 2. So for example, if we take the same calamine lotion example that we're making 30 mils, we determine the scaling factor or the converting factor by the following formula. We determine the amount to be made and we divide that by the total amount in the master formula. So here, the total amount that needs to be made is 30 mils, while the total amount in the master formula is 100 mils. So the scaling factor is 0.3. So it means then that I am going to be reducing my formula by a scale of 0.3. So what does this look like? It looks like me multiplying that 0.3 by each of the 4 ingredients. That's the calamine, the zinc, the glycerol, and the bentonite by 0.3 to get the reduced amount for 30 mils. So for calamine powder, I'm multiplying it by 0.3. Similar for zinc oxide, glycerol, and the bentonite. And notice we are decreasing the amounts by a third, basically. So of course, the new formula will look like this, similar to what we had when we did the ratio and proportion. So that's another way of doing it. It's quicker. Students find that the scaling factor is quicker, but you must determine what amount you need to make or prepare and divide that by the total amount in the master formula in order for you to use the scaling factor. And notice we did not multiply calcium hydroxide by 0.3 because again, it is used to make up to the final volume of 30 ml. So we don't know what the volume of that will be. Okay, so this is an example that I would like for you to do when we come back next week, Thursday. I'd like to see or hear from you how you had approached it, right? So it requires you to prepare 2.5 liters using this master formula below, and I'd be happy to see if you will be able to carry out those calculations. All right, so just summarizing this lesson, reducing and enlarging formulas allow the compounder to prepare medication that is listed in a larger or smaller proportion than the original formula. Whether scaling up or down, the pharmacist or the pharmacy technician must be proficient in such calculations, and it can be done by using ratio and proportion or using a scaling factor. I thank you so very much for your attention, and we will pick up next week, Thursday, by doing some questions on this lesson. Have a wonderful day.